now I want to show you what are the low power possibilities on U5 with timers and low power DMA. First step will be generate PW signal with change of data cycle by the low power DMA. Next step will be measurement of this signal using other timer and low power DMA. And last step will be sending this measured data by low power UART with using LPDMA, and we will stop core in stop 2 mode. First step will be generate PW signal. We will use channel 1 with frequency approximately 50 Hz. Data cycle will be changed in 5 steps, approximately each 1 second. And compare capture register will be updated by update event. And ARR shadow register will be set at rising edge of output signal to clear update event flag, which is necessary to continuous mode of counter working. Now we can start creating project in Cube IDE. We will select U575ZE and we will select this one. And next U575 LPTIM, and we can go directly to project. There is information about our cache, but you will see later this information about what is necessary for U5 project. First, we set low power timer 1 to generate signal on channel 1. Signal will be generated on GPIO C1 port with period 640 and with for the start with 25% data cycle. Other settings, update end of period and compare. Now we can continue with enabling switch mode power supply. In the power section, enable low speed oscillator, and then we will continue. Now we can continue by enabling switch mode power supply. It's a little bit hidden in settings, power and thermal, power, low power, both must be enabled. and now it's possible set power regulator SMPS. It is done, and now we can continue by enable low speed external oscillator with crystal. It is in RCC systems section. Now we enable iCache in one-way mode. Next step is prepare two channels of low power DMA to work in linked list mode and as circular. And both channels must be circular for us. Then we can continue create linked list queue for update event and for compare capture event of timer 1. First will be for compare capture. Linked list it's here. Now queue will be named LPTIM PWM. It will be for low power DMA and in circular mode. For circular mode it's necessary to set first node name, and there will be only one. That is simple. Request will be from update event, but compare capture register will be changed. Now we are set these settings. Update request from update event, memory to peripheral. We will be increment address in RAM and not increment address in hardware in peripheral. LPTIM update event, transfer from memory to peripheral, source increment of address will be enabled, UART white, and destination is also UART. There is no handling destination necessary. Then we will configure source and destination address and number of transfers. The easiest way is use this cheat sheet where everything is prepared for us. Better will be all changes safe, and we can continue by next queue. Be at new list. Okay. For low power DMA, circular mode, and first node is named R node. For this node we will use software request because this transfer will be requested and forever, but it will be triggered by compare capture event. Transfer is from memory to memory, but address will be set to peripheral register. There is necessary set worldwide, and trigger will be on rising edge from the channel 1. And runtime, we will copy this variable to this register. Writing to this register clear the update event flag, which is what we need to generate update event. Without this writing to this register, the generation of update events is stop and waiting for clearing of this bit. Okay. Save, now generate for this moment. Next one is setting 160 MHz for core and low speed external oscillator for low power timer. In the clock setting we will use clock from PLL, and that is necessary put only 80. Now clock are okay, and setting for low power timer is here, and we only switch to low speed external. And now we will configure code. There are necessary some changes, but first of that we will save IOC file and generate code. Then we must add new section for SRAM4, which is only section where is low power peripheral works in stop mode. SRAM4 memory section is prepared, but not section in this memory. That's it. Next modifications will be in main H file. There will be externals for some variables and constants which define the size of these variables. For private definition, And now we will modify linked list C file, and everything what is prepared for linked list is necessary put to SRAM 4. Unfortunately, it is not done from QMX, and we will replace also section user code, because here is imported main header file. And now we will modify main C file. First we will include linked list header, and then we will create some private variables to control our code. And last step, it's copy of the user code, which prepare array with data cycle values, set necessary variables, start low power timer, and start DMA to change the parameters of generated pulses. Now we can build project. Download it to the board. And after start, we can see a result on oscilloscope.